All right, so last time we talked about the differences heat capacities and said water takes a lot of energy to heat up, metals don't. But now we can talk about it in terms of numbers, right? How much heat is required to make it this temperature or that kind of thing. And so these are the heat capacity calculations. These are an example of what I would call plug and chug type of problems. And so there's kind of like three major steps to these plug and chug problems. The first step is to find the equation, right? So you have to read the word problem and think about, which equation I'm going to use. And this is probably one of the more difficult steps, and it's something that really only comes with practice and understanding of what the equations are saying and what the word problem is saying. The second step is to plug in your known variables. Right, so we found our equation, we're reading our word problem, we're going to extract information from that word problem and plug those numbers into our equation. This step can also be a little bit tricky sometimes, depending on what units that you're given, because you may have to do unit conversions in between. And then finally, the third step is to use algebra to solve for the unknown, right? So in your equation, there's one variable that you don't know. You're going to plug in your known variables, solve algebraically for that unknown, and that's generally your answer. So the equation that we're going to introduce here is Q equals M capital C delta T. Some people call this Q equals MCAT because the delta kind of looks like a big A, so cat. You can call it whatever you want. Q is obviously our heat, right? That's the amount of heat that we're adding into the situation. And then we're going to heat up some mass. So this is the mass, usually in grams. And how much it's going to heat up depends on the specific heat, right? How much energy it takes to heat that thing up. So that's specific heat. And that's in units of joules per gram degree Celsius or joules per gram Kelvin. In this case, we're talking about a difference, so it doesn't matter which one you use, they're interchangeable. And then finally, delta T is the change in temperature, right? Okay, something went up by 10 degrees, it went up by 30 degrees, right? That's your delta T. However, we can think about delta T in another way, right? And that's TF minus TI, where the F is your final temperature and your I is your initial temperature, right? So if something went from 25 degrees Celsius to 35 degrees Celsius, your delta T would be 10 degrees Celsius. So you can write this equation like so, or you can write it as Q equals MC, and then in parentheses, TF minus TI, right? Where this is just delta T. All right, let's go and take a look at an example of a problem and how we're going to solve it through our kind of plug and chug method. So first thing we need is this little table that I'll provide you with if you need it, or maybe I'll just give you the mass or the specific heats, whatever. So our problem says 25 grams of an unknown metal requires 225 joules of heat to go from 20.0 degrees Celsius to 35.0 degrees Celsius. What is the metal? Right, so the question is asking us what the metal is, and we're giving a table here where we have different specific heats of different metals. So what we need to do is solve for the specific heat, and then we can discover which metal it is. So let's take a look at our problem and how we're going to plug that in. Obviously, the first step of this kind of problem, find the equation, is relatively easy for us because we're going to use the equation that we just learned about, right? So Q equals MC delta T, or you can think about it as Q equals MC TF minus TI. It depends what kind of information you're given. If you're just given the difference, use the delta T. If you're given both temperatures, use the TF and the TI. And then let's also break down this problem and think about other ways that I could maybe not necessarily trick you, but make the problem a little bit more difficult. So for example, we have 25 grams. That's obviously our mass. So we want to plug that in for M. And in this case, I just gave you grams. But I could have given you moles, right? I could say 25 moles of some metal, right? And then you'd have to use the molar mass to solve from moles to grams. I could have given you a volume, like it's a 25 milliliters, and then to go from volume to grams, you'd have to use density. Or I could have given you, for example, kilograms, right? Maybe like 2 kilograms of material, and then you'd have to convert from kilograms to grams, which we know how to do. So just think about the different ways that I could, plug in different numbers. All right, then we take a look at what other value we have. We have 225. That's the heat, right? So that's going to go into our Q. Another thing I could have given you there is kilojoules instead of joules, and then you would have had to convert. And then it goes from 20 degrees Celsius. So that's our initial temperature. So that'll get plugged into TI to 35 degrees Celsius. That's our final temperature. So that'll get plugged into TF. And so what we can see here is that we have almost all of the variables, right? We have just one variable that we don't know. And so that's what's known as our unknown variable. And when we're solving algebraic problems, there can only be one. If you have more than one unknown variable, you're missing some piece of information or something like that. We can only ever solve for one variable. And so what I see a lot of students do now is they start plugging the numbers in and try to solve. That's generally not the best methodology to use. You really shouldn't plug in numbers yet. What you should do before you plug in the numbers is isolate for your unknown variable. So for example, I have my Q equals mCTF minus TI. And then this is my unknown variable. What I should do is I should isolate that first. And the steps that I would take to isolate it is the first thing I would divide both sides by m to move this m on that other side. And then I would divide both sides by TF minus TI in parentheses, right? To move this side over to this other side of that equation. And so what I'll do, I'll draw this little kind of squiggly line, which basically means that I've reorganized the equation algebraically. And I always put my unknown variable to the left, so it's very obvious what I'm solving for. And then you have your new equation. So C is equal to Q over M times TF minus TI. And now we can plug in chug. So you don't have to do it this way. You can, plug in your numbers earlier, but it's generally better to not plug your numbers until the end because this gives you a better understanding of what you're doing. The work is presented in a neater way, and it helps you understand the problem a little bit more once you get more comfortable with these algebraic equations related to physical compounds. So now we just plug in our numbers. So for Q, we had 225 joules, and we should include the units here. For the mass, we had 25 grams, 25.0 grams. And then for TF minus TI, we had 35.0 degrees Celsius minus 25.0 degrees Celsius, which we could also write as just 10.0 degrees Celsius because the difference is 10. And then we think about the units here. In this case, we don't have any units that are the same. So none of the units are going to cancel out, right? They're all just going to be what they are. And so on top, we'll have joules. Underneath, we'll have grams. And then we'll also have degrees Celsius. If we think about these units, they match exactly our units here, right? So the units can be a big help to know that you're on the right track. And then we solve algebraically, you get 0.900 joules per gram degree Celsius rounded to 3 sig figs, right? So we need to insert 3 sig figs to indicate that's how much our uncertainty is. In terms of these units, we can write them one other way. So x to the -1 is equal to 1 over x. So instead of writing joules over grams degree Celsius, we could have also written joules as grams to the negative, or joules times grams to the -1. degrees Celsius to the -1, right? So these -1s just indicate that they're underneath or they're in the denominator. Not too important. Anyways, let's go ahead and check our answer, right? So now we know our metal has 0.900 joules per gram degree Celsius as the specific heat. We take a look at our table, see which one matches, and we find that aluminum matches, right? Note that our uncertain digit is different, but that's fine because it's the uncertain digit. And so our compound here is aluminum. Overall, in general chemistry, usually kind of low-level physics classes and low-level engineering classes, there's going to be a lot of plug and chug. A lot of these types of problems that, some kind of word problem, you have to figure out what equation you use. You have to, find your values, put them in there, and then you have to solve algebraically, right? Oftentimes the hard part is going from the word problems to the equation. Unfortunately, that's also the most important part because that's really kind of what develops that critical thinking ability. Solving equations, we can have a computer do that for us. Going from a word to an equation, most computers cannot do that. And unfortunately, there's only one solution, and that's to practice, right? The more you practice, the more you get familiar with using the equations, the better you'll understand them, and then the easier these problems will become.